Hi everyone and welcome to my channel. In this video my topic is transformations and the subtopic is reflection. I plan to do reflection using matrix method and then using ruler and protractor only. This is really done in Form 4, Form 5 and is covered in math. So please stay tuned to see what I have in store. Reflections in real life mean the same as reflections in math. It's the same concept. There's an object here, there's a mirror line which is here, and there is lastly the image, right? Now the distance between the object and the mirror would be the same as the distance between the mirror and the image. Now even though in this particular diagram it doesn't look the same, mirrors tend to have that sort of feature where they appear as if they have depth when they are really just a flat surface, right? But when we look at the mirror, the distance that we have between ourselves and the mirror line and the distance between that mirror line and the image that is created is usually the same. So this is the same concept that we're doing with math. Now in math though, there are two methods. There's the matrix method and there's the method where we use the ruler protractor only on graph paper. With matrix method it's pretty simple, but however it only caters for specific reflections. So I'm going to give you a list of that now. These are the various matrices that follow particular rules of reflection. So reflect along the x-axis, this is the first one, 1, 0, 0, minus 1. Reflect about the y-axis, minus 1, 0, 0, minus 0, 1, etc. Right? So please take note of these. Now let me start a question. This is my first example. We have a triangle PQR such that P is 2, 1, Q is 5, 4, and R is 5, 1. We need to do these things. So the first thing we need to do is draw up this triangle here. So I'm going to plot these 3 points. So now that I have this triangle, now I want to read. Determine the reflection of this triangle when it is reflected along the line y is equal to x. So I need to draw this line. Now if I want to reflect along this line y is equal to x, the first thing I need to do is to draw up that line. But that line is very easy to draw because y is equal to x means every value of x is equal to y. So I could simply plot like 0.11 and say 4, 4 and then connect this, and this is this red line I will get. Now for me to reflect this now I need a protractor. So I'm going to place the protractor along the red line here and I'm going to put it in such a way that I want the 90-degree marker to go through P. So I want to create a 90-degree angle here, right? So once I have established that my 90-degree marker is going through P, I will mark off where that point is, and I will also visually mark off where is the middle section of the protractor. So once I lift my protractor away from the paper, I will then place a dot on the red line. Now once I have this dot, I will connect this marker and this dot here to create one straight line that will be going through P and making a 90-degree angle between the red line and this now newly made blue line. Now the reason why we need to draw this line is because we need to measure this point P has to be 90 degrees from this line, this red line here, and it has to be the same distance. So meaning this distance here, this yellow distance here, I'm going to measure it. And then I'm going to measure the same thing here on the other side because P is going to be somewhere on this side here, anywhere here, right? Now, once I've established where that is, which is really just half of a unit here, I will put in my P dash. The same process that I just did to establish P dash, I have to repeat this for Q and for R to get R dash and Q dash, right? So now I'm going to do it again. I will place the protractor along the red line, which is my mirror line. I will establish that 90-degree marker that goes through Q. I will mark off where that is and remove the protractor to get that center point. Once I have this center point and this little stroke that I made, I will extend it and make a long blue line. I have removed the protractor and I now have another blue line. I am going to measure the distance from here to Q. And I'm going to measure that same distance going upward. So usually you use a ruler for this, but because I'm using the grid, I could just average here. And I'm getting here to be Q dash, right? Now, I repeat the same process for R. I am measuring this distance here now, and I'm going to measure it up here as well. And it looks like I'm getting. So the R dash is now this point here. Now I'll remove these lines just so that you all can see my triangle clearer. Connecting the 3 dots, right? I now could show you that I've gotten P dash, Q dash, R dash triangle, right? And it looks really like it's a reflection along the line y is equal to x. It's just that my triangle, these sides are not straight, but that's okay, right? Of course, when you're doing it on graph paper, you use a ruler and a pencil, right? I'm only using these colors to explain, but really when you're doing this on graph paper, you should just be using ruler and pencil, and of course a protractor. So we are finished with this piece here. Now let's move on. Determine the reflection of this triangle, which is this red one now, along the line y is equal to the x-axis, sorry, the y-axis, to create another one. Now to do this, again, this is now our mirror line. We have a mirror line here. Here's our object, and our image may be somewhere on this side. Now this mirror line here already has these lines across it that make 90 degrees. So in this particular case, I do not need to use a protractor. I could just simply draw a straight line from here to here, measure this is 1 unit, and I'll measure 1 unit on this side, and here will now be R double dash. Same here, and same here. Now this is only because these straight lines that come with the graph paper are already 90 degrees to our mirror line. If our mirror line was not the y-axis and it was another line, y is equal to x plus 4, or whatever it might be, I cannot do that. Just like what I would have to follow the process like what I did with my part A, right? Now repeating this now, Q dash is here, and that is 1, 2, 3, 4 units away from here. So I'll go 1, 2, 3, 4 units here, and this will be Q double dash. Connecting them all now, I get this. So this is how I do these two parts here using ruler and a protractor only. If I was asked, however, to do this using matrix method, then this is what I would do. This first line, which is what the reflection is y is equal to x, I would have to place that matrix here, which is 0, 1, 1, 0, and then I have to put my 3 points here, P, Q, and R going vertically like this. And I'll have to multiply these two matrices. Now if you need some revision with your matrices, of course you can check my other video, and once we've multiplied these, we'll get these points here. So this confirms, here I have P dash here on my graph is 1, 2, and look, I have it here as well. 1, 2 is P dash, Q dash is 4, 5, I have it here as well. R dash is 1, 5, and look, I have it here as well, right? So we got the same thing using two methods. Now again, I'll repeat the same process. This is my matrix method solution for part A. Part B, I need to reflect using the y-axis. The y-axis now, that matrix is, again, now I'll put these P dash points multiplying these here now, I'll get P double dash, Q double dash, and R double dash. And that will work out to be and that confirms the values that I have here. P double dash is minus 1, 2, which is what I have here. Q double dash is minus 4, 5, which is what I have here. And R double dash is minus 1, 5, which is what I also have here. So I've done it using the two methods. Now the last one here now, in part C, it says write down a single transformation that maps P double dash, Q double dash, R double dash to PQR. So that means I want to get a single transformation that will map this triangle here to this triangle, right? Now what it looks like is that this may be a rotation. So if I need to find the center of rotation, I will simply have to connect matching points together, meaning I will connect the point P to the point P double dash with a straight line, right? So something like this. Of course my line is not straight because I'm using a pen, right? I'll connect R and R double dash again like this, following the same procedure I did for P and P double dash. Now once I've done this, I want to bisect this line, so then I'll have to use a compass, or I could use the midpoint finding regular coordinate geometry, and you can check again. I have another video on coordinate geometry to revise that. So I'll get a midpoint here, say it's around here. Similarly, I will do the same for R and R double dash line, get a midpoint here as well, and I'll get that green point. Now what I have to do with this red point now is I have to draw a 90-degree line, a perpendicular line, perpendicular to this red line and this point, right? And when I draw that point, when I draw that line, sorry, that line will kind of come up like this. Oops, sorry, something like that. And then when I draw the other line now to the green point, I would get these two lines. This black line is the perpendicular line, perpendicular bisector of P and P double dash. This yellow line, guys, is the perpendicular bisector of R and R double dash. And wherever they intersect here is actually the center of rotation. Now, I will produce another video on rotation that will explain this in a lot more detail. But seeing that this was already in our question here, I just wanted to tackle it. Right, now from here now, I will connect here P double dash to the center of rotation and P to the center of rotation also, and I will measure this angle. This angle here is 90 degrees. So this is actually a rotation of this triangle 90 degrees clockwise to PRQ, or it is an anti-clockwise rotation that is in this direction of 270 degrees of P double dash, Q double dash, R double dash to triangle PRQ. Now this is the end of my first example. Example 2 now. We want to find the mirror line that would reflect triangle ABC to A dash B dash C dash. So this is triangle ABC here, and this is A dash B dash C dash. So we want to say, okay, how are we going to move this green line here so that we could get a mirror line that is in between the two? Now sometimes you will be given questions like this. That is, you're given the object, you're given the image, and you're not given the mirror line. So what you have to do is you have to connect matching points. So that is A dash and A. What I'll do is I will draw a connecting line to connect the two. Same I will do for B dash and B and C dash and C. Now once I've done this now, what I need to do is I need to bisect these lines, right? Because remember, the distance between an object and the mirror line must be the same as the distance between the mirror line and the image. So if this is the entire distance here, then half of this would actually be the mirror line. So once you measure this and you cut it in half, it may be around here, right? Now you have to do this accurately, right? You're not doing it like how I'm doing it here, only because I'm teaching virtually, right? Now for P and P dash, same, it will be around here, and for C and C dash, it would probably be around there. Now once I have these three midpoints, or I could even do this with two midpoints, I don't have to do all three, then I connect all three and I move the green line to there. And this is what it would produce. The green line will now move here, and this looks like this is the perfect mirror line. Now for us, we would need to definitely get the equation of this line. So of course you have the point C here, and well, you could use any 2 points, say this point here and this point here. So you know the plus C would be 2, and we use y is equal to mx plus c to find that. This is the working to get the mirror line. So this, everyone, is the equation of the mirror line for example 2. This takes me to the end of the video. I hope that you all understand. I did a reflection question where we did matrix method and the regular method with respect to using ruler, protractor alone. And we also did a question where we have to find the mirror line. I hope you all understand. Feel free to like, share, and subscribe.